All right, this video is going to walk you through graphing for Carts and Masses Part 2, and we're also going to find the slope of our line. So you might notice that I've already got my axes set, and that's because we're going to pre-scale this one. You don't have to make it fit your data because everybody's data should fit within a particular range. So on your graph paper, if you have it, or on your own paper, you're going to go about 3 lines in from the left and draw your y-axis. And you're going to go about 2 or 3 lines up from the bottom and draw your x-axis in. Your y-axis you can see is labeled force, and each line is going to represent 0.2 newtons of force. So you can go ahead and just pre-label them, 0.2, 0.4, 0.6, 0.8, all the way up to 2. You shouldn't have any force that is higher than 2. On your acceleration, same scale. You're going to go ahead and pre-number 0.2, 0.4, 0.6, 0.8, all the way out to the edge of your paper. You should be at least out to 4.0. You can see that I've gone out to 4.2. Go ahead and pause the video until you get your axes set so that you can go through the graphing portion with me. So now we're going to plot our points. Now the data that I'm plotting is not going to be the same as your data, so please use your own numbers and not mine. And just really quickly, I'm going to put my dots in here. So for my first data point, I've got 0.5 newtons and about 0.6 for my acceleration. So I'm going to put a dot there. For my second one is right about here. My third one is right about here, and my last one is all the way up right about here. So I've got my 4 data points plotted. Now we're going to draw our best fit line, but we're going to do it a little bit differently. You can take a ruler and you can try and find a line that kind of goes roughly in between. But here's a trick for this particular lab. It doesn't always work, but it does work for this lab. And you should be able to find a spot where you've got 2 points that are on the line, and then you've got 1 point above and 1 point below. If all 4 of them fit on the line, awesome. If you can get 3 of them lined up, even better. But for mine, I can line it up so where my first and third point are actually on the line. And because I'm using a clear ruler, you can see this data point would be above the line and this one would be slightly below. So this is actually going to be a perfect best fit line for this data. And just draw that in. So your best fit line, remember, should be about average. It should go sort of through the middle of your points. So if you've got a whole bunch above the line, then that's not your best fit. If you've got a whole bunch below the line, again, that's not your best fit. You need to be about half and half, some on the line, some above it, some below it. And you can see for mine, this point is about the same distance above the line as this one is below it. Maybe a little bit more, so I probably could tilt my line up just a little bit, but I don't think it would make that much of a difference. So now that we've got our line drawn in, we're going to ignore these red dots that I've plotted. Now I'm just going to look at the line itself, and I want to find the slope of the line. The easiest way to find the slope of a line is to look for a place where my line crosses over an intersection of these blue graph paper lines, because I know exactly what those lines represent. If it's going in between, like right here, I don't know exactly what that number is. I can estimate, but I don't know for sure. So, but if it crosses over an intersection, like right here, okay, if you look closely, you can see that it goes exactly over that intersection between those blue lines. And I'm going to run up. I'm going to try and find one farther away, as far away as I can, and I see one right here. So I'm going to circle those 2 points. That's my point 1, That's my point 2. Remember, our slope is y2 minus y1 over x2 minus x1, rise over run, force over acceleration. So first let's find the coordinates of my points. So my point number 1, my x coordinate, 0.4 meters per second squared. My y coordinate is 0.4 newtons. Always put your units in there so you remember what you're working with. My second point, the x coordinate is 3.2 meters per second squared. My y coordinate is 1.6 newtons. Now I'm going to find my slope. You can do it right here in the blank space in your graph paper, or you can show your work on your journal. So y2 minus y1, 1.6 newtons minus 0.4 newtons over x2 minus x1 over 3.2 meters per second squared minus 0.4 meters per second squared. Okay, again, notice I've got my units so I know what I'm working with. When I plug that into my calculator, 1.6 minus 0.4, 1.2 newtons over 2.8 meters per second squared. Now some of you want to leave it like this. Don't ever leave it like that in a science class. You need to finish this out. What does that tell me? And hopefully you remember force over acceleration is equal to mass. So what we're finding here is the mass of our cart system. So 1.2 divided by 2.8 gives us 0. We're going to keep 3 significant figures here, and I will tell you why in just a moment. 0.429. I'm going to round that up to a 9. 429. And because we know that we're finding mass, our units on this, force over acceleration, are going to be kilograms. 0.429 kilograms is the slope of our line. If you weren't writing your work on your journal page, make sure that you write your answer on your journal page where it asks for the slope. Now, here's why it's important to keep 3 significant figures. Think back to your cart system. You had a total of 440 grams, which is 0.440 kilograms. 3 significant figures. So we want that to match with our slope here. Now we're going to find percent error. Our actual in this case, 0.440 kilograms. That's the total of the cart plus the hanger for every single trial. If you go back through your journal and add up the cart mass plus the hanger mass, it's going to add up to 0.440 kilograms every single time. So this is our actual. Our calculated in this case is going to be the slope of our line, 0.429, or whatever you got for the slope of your line. If it's way off from this, you might want to go back and double check your math. So actual minus calculated divided by actual, and then times 100 will give us our percent. So here's how you type this into your calculator to make double, triple, quadruple sure that you're doing it correctly. Do the first part of your fraction, 0.440 minus your slope, hit equals, then divided by the actual, 0.440, hit equals again, now times 100. So my percent error is 2.5%. It's pretty close. Watch the next video if you need help answering your analysis questions.